It's Carly McAvoy. I'm writing logarithmic equations, exponential equations, and then solving for x for some of these, or the variable could be y. And first of all, we're just going to identify in a logarithmic expression, if it's written this way, log base u of z equals w, that then we can rewrite it with u to the w equals z. That's the transformation. And you can see that the base u is the base in this exponential expression as well. And what we're asking is u to what power equals z? And then what we're trying to get it to equal is that z right here. So in this first expression, the base is u, and the base log base 8 means that our base is u, which is 8. W is the power that we want to raise this to. And so 8 to the 1/3 power equals, and what the z is what that expression equals. So z equals 2. So that's the UWZ. And then if I want to write that in that format, it says 8 to the 1/3 power equals 2. You could do a cubic root on your calculator or raise it to the 3rd power to see that that's true. Here we have a base of 3. So u is our base. That's 3. The w is always the exponent, which is the variable, excuse me, or the number to the right of the equation here. And so that's going to be 7. And then z is what 3 to the 7th equals, which in this case is 2,187. 3 to the 7th power, 3 to the 7th power equals 2,187. And finally, our base here is 3. We're raising that to the power of 2 to get 9. So it looks like that. 3 to the power of 2 equals 9. So they can be a little more complicated. Let's look at these where we have log base 3 of 2x minus 5 equals 5. But I can still tell you that 3 is my base. I'm going to raise that to the 5th power, and it's going to equal this part right here. So it looks like this. 3 to the 5th power equals 2x minus 5. That's rewriting it into exponent form. But if I wanted to solve that, I would take 3 to the 5th power, which is 243. I would add 5 to both sides, get 248 on the left side, and then divide by 2, and I would see that x is 124. For the second one, I can see that 5 to the y power is going to equal 625. So I'm going to write it that way. My base 5 to the power that's over here equals 625. And then what I'm going to do is rewrite 625 with the same base on the right. And if you're not sure, I don't know what 5 to the 4th is, just take your calculator and do 5 to the 2nd. Well, that's 25. 5 to the 3rd, 125. 5 to the 4th, until you get that number that matches. For these simple ones, they're going to match for you eventually. And so then if I know the bases are the same, then I know that the powers must be the same. So it must be y equals 4. Over here, our base is 10 to the y power equals 1/10. I just wanted to write it on the other side so you could see that. This is 10 is our base, y is our exponent, equals 1/10. And I know that 10 to the 1st power would be 10. This is definitely smaller than that. 10 to the 0 power is 1. It's even smaller than that. And so what I did here was just rewrite 1 over 10 as 10 to the negative 1. Now I can see that my bases match and y must be negative 1. And then down here, if I want to write an equation into logarithmic form, I know that 5 is my base, x is the power that I want to raise it to over here on the other side, and 25 is my z essentially. And so if I delete that, my square there, you can see that 5 log base 5 of 25 equals x. And if I wanted to solve that up here, I could, because 5 to the 2nd power is 25, so x would have to be 2. And I already showed you how to solve that up here, but if I wanted to just rewrite it, my base is 4, my power is 3, and it equals 5x minus 1. So it looks like this. Log base 4 of 5x minus 1 equals 3. All right, that should do it for you. Have a fantastic day, and I'll see you next time.